Oh, I'm so sorry. I was just thinking about how to go about this video, but really glad that you people are here and we are going to solve some questions on the nth term of an arithmetic sequence. Now, in the last video, we learned about how to derive the formula for the nth term of an arithmetic sequence, but this video is going to tell you how exactly to solve some questions. And there are some typical questions also that we are going to do in this video, but do stay till the end of the video because in the end, I'm going to give you something which will change the way you think about arithmetic sequences and the nth term. So come on, let's nail it. So the first question that we have is that we have an arithmetic sequence or an arithmetic progression which is 14, 9, 4, -1, -6 and so on, and we have to find the following four things out of it. We have to write the next two terms of the sequence. The second part is that we have to find the recursive formula for the sequence. A recursive formula is a formula in which we just enter the term number and we get the term, what is the value of that term. Using the recursive formula, we have to check whether the sixth and seventh term of the sequence which we guessed earlier, is that correct or not. And the fourth part of the question is that we have to find the 18th term of the sequence. Now, in case at any time you find it a problem that how did we get this formula for the nth term of a sequence, I've done a video on deriving the formula for the nth term of a sequence. Now, if you haven't seen that video before, it is linked in the description box below, or you will also find a link to it at the end of the video. Okay, so first of all, let's start by writing the sequence ourselves, which is 14, 9, 4, -1, -6. Now, seeing this sequence, we know that 14 is the first term, which we can write as A, and then we have to find the common difference. Common difference is found out by taking any term and subtracting from it the previous term. So in this case, I'll take the second term and from it I'll subtract the first term, so that becomes 9 minus 14, which gives us a common difference of -5. Now always remember that the common difference is a term and subtract from it the previous term. It's not the previous term minus the next term, it is the next term minus the previous term. So you'll never go wrong with it. Okay, so as we see in the progression, let's start with part number 1. We have to guess what the sixth and seventh term of the sequence is. So we can see that in each term 5 is being subtracted from it. So 14, we subtract 5, we get 9, 9, we subtract 5, we get 4, 4, we subtract 5, we get -1, -1, we subtract 5, we get -6. So obviously the sixth term is going to be -6 and we subtract 5 from that. So that gives us -11, and the same way the seventh term would be -11 and we subtract 5 from that, which is -16. So part 1 is done. Let's come to part 2, in which we have to find the recursive formula of the sequence. So let's start by writing the formula for the nth term of an arithmetic progression or a sequence, which is an, or we can also say Tn, which is the nth term, is equal to A, the first term, plus n minus 1 times D, the common difference. So let's substitute the values. We know that the first term A is 14 plus n minus 1, we don't know what n is, so let it remain n minus 1, and the common difference is -5. Simplifying this, we can write it as 14 and then we'll distribute this -5 to inside the bracket. So -5 times n gives us -5n, and -5 times -1 gives us +5. And simplifying this further, we get 19 minus 5n. So the recursive formula for the sequence is an is equal to 19 minus 5n. So let's write it on the side here that an is equal to 19 minus 5n. So that's part 2 for you, and let's get rid of this and let's come to part 3, where we have to use the recursive formula to test whether our sixth and seventh terms were okay. So coming to sixth term, A6 is going to be 19 minus 5n, and instead of n, I'll place the value of 6. So it becomes 19 minus 5 times 6, which is 19 minus 30, which gives us -11. So yes, that's what we got earlier also, which means the sixth term is correct, and the seventh term would be 19 minus 5 times 7, because in this case n is equal to 7. So that becomes 19 minus 35, which is -16, and that's what we had got earlier also. So that's the third part. Let's get rid of this also and come to the fourth part, where we have to find the 18th term of the sequence. So again, A18 or T18 is going to be 19 minus 5 times 18, because in this case n is equal to 18, which becomes 19 minus 90, which gives us negative 71. So that means the 18th term of this sequence or this progression is going to be negative 71. Hey guys, sorry for the interruption. I just wanted to interrupt you and tell you that if you're liking the video so far, it would really help me if you could just give a thumbs up to the video, and do not forget to click on the subscribe button. Also, it will help me quite a lot. Thank you. Let's continue. Okay, let's come to question number 2, where it says that sum of the 4th and the 8th term of a sequence is 24, and the sum of the 6th and the 10th terms of the same sequence is 44, and we have to find the first 3 terms of the sequence. So let's start by writing down what is given to us. So we know that T4 plus T8 is 24, and T6 plus T10 is equal to 44. Now looking at the first equation, we can say that T4 can be written as A plus 3D, because it is A plus n minus 1 times D. So n in this case is 4. So A plus 4 minus 1, which is 3. So A plus 3D can be written as the 4th term, and same way the 8th term can be written as A plus 7D, and the sum of those two should be equal to 24. The same way, looking at the second equation, we can say that A plus 5D, which is the 6th term of the sequence, plus A plus 9D, which is the 10th term of the sequence, the sum of those two should be equal to 44. Now let's take the second equation here and simplify it further. So we have got 2A's, so that becomes 2A plus 14D. So 2A plus 14D should give us 44, and when we simplify the first equation, again we get 2A plus 3D plus 7D gives us 10D, which should be equal to 24. Now let me subtract this equation from the first one. So obviously the signs will change, and in that case 2A minus 2A, that gets cancelled out. 14D minus 10D gives us 4D, and 44 minus 24 gives us 20, which means 4D is equal to 20, and dividing both sides of the equation by 4, we get that D is equal to 20 divided by 4, which is equal to 5. Now once we have got the value of D, we can substitute it back into any of the equations above and find out the value of A. So let me take the second equation in which the numbers are smaller. So 2A plus 10D is equal to 24. So that becomes 2A plus 10 times 5, because D is 5, is equal to 24. We'll take 50 to the other side, so that gives us 2A is equal to 24 minus 50, which gives us negative 26, and dividing both sides of the equation by 2, we get that A is equal to negative 13. Now since we have got both the value of A and D, we can find the first 3 terms of the sequence. So the first term obviously is negative 13. The second term is we are going to add 5 to that, because the difference is 5. So negative 13 plus 5 gives us negative 8. And the third term, we are going to take the second term and again add 5 to it. So it's negative 8 plus 5, which is negative 3. Okay, let's come to question number 3. Question number 3 says that we have to find out whether 51 is a term of this arithmetic sequence or not. So the sequence, as we can see, is 5, 8, 11, 14. And we have to check whether 51 is a term or not. So for this, let us start by assuming that 51 is a term of the sequence, and let it be the nth term of the sequence. So we'll start by writing the formula of nth term, which means Tn is equal to A plus n minus 1 times D. Now in this sequence, it is very clear that the first term that we have is 5. So A is equal to 5. And the common difference, we'll again take the second term, subtract from it the first term. So 8 minus 5 gives us a common difference of 3. And since we had assumed that 51 is the term of the sequence, so we can write it as 51 is equal to A, which is equal to 5, plus n minus 1 times D, which is equal to 3. So to simplify this, let's start by taking this 5 to the other side of the equation. So we get 51 minus 5, which is equal to 46, and on this side we are left with n minus 1 times 3. Let me take this side of the equation and write it first. So we'll distribute the 3. We get 3 times n is equal to 3n, minus 3 times 1 gives us 3. So 3n minus 3 is equal to 46. Let's take 3 to the other side. So that leaves us with 3n on the left hand side, and the right hand side becomes 46 plus 3, which is equal to 49. To find out the value of n, we'll then divide by 3. So we get n is equal to 49 over 3, which gives us 16 1 by 3. Now we were supposed to find the value of n. N is the nth term of a sequence, which means it can be the first term, the second term, the third term, or whatever, but it can only be an integer value. It can't be 16 1/3 term. So obviously we can say that since n is not an integer, therefore 51 is not a term of the sequence. Okay, so let's come to the fourth question of the video, and the fourth question gives us two arithmetic sequences, and we have to find the value of n for which the nth term of both the sequences is going to be the same. So looking at the two APs, or the AP stands for arithmetic progression, which is also an arithmetic sequence. So let's look at the two APs. The first AP, we can see that A is the first term, which is equal to 13. D is the difference between the second term and the first term, or any term minus the previous term. So in this case, let's take it as 19 minus 13, which gives us 6 as the value of D. So obviously the nth term of this sequence is going to be Tn is equal to A plus n minus 1 times D. Substituting the values, we get 13 plus n minus 1 times 6. Distributing the 6 and simplifying it further, we get 13 plus 6n minus 6, and simplifying it further, we get 6n plus 7. So the nth term of this particular arithmetic progression is 6n plus 7. This is also called the recursive formula for this sequence, as we discussed earlier. Now let's look at the second arithmetic progression that we have. In that, we know that the first term A is equal to 69, and the common difference is the second term minus the first term. So 68 minus 69, which gives us a common difference of -1. And the nth term of this sequence is also going to be Tn is equal to A plus n minus 1 times D. Substituting the values, we get Tn is equal to 69 plus n minus 1 times -1. Distributing the -1 and simplifying the equation further, we get 69 minus n plus 1, which simplifies further to 70 minus n. Now we have been given in the question that the nth term of both the sequences is going to be the same. So we can say that 6n plus 7 should be the same as 70 minus n. And now from this equation, we have to find the value of n. Pretty simple. So let's take n to the other side. We get 6n plus n, which makes it 7n, and let's take this 7 to the other side. So that gives us 70 minus 7, which is equal to 63. So if 7n is equal to 63, therefore n is equal to 63 divided by 7, which is equal to 9. And we have to find the nth term also, which is going to be the same for both the sequences. So the ninth term we have to find out. Let's use the recursive formula that we got for any of the two progressions. So it's 6n plus 7. So the nth term is going to be, or the ninth term is going to be 6 times 9, because n is equal to 9 now, plus 7. 6 times 9 is 54, plus 7 gives us 61. So 61 is the ninth term of both the sequences, and it is going to be the same in both the progressions. Okay, so before we go to the last and final question of this video, I also wanted to tell you that I've done for you guys a special course on the nth term of an arithmetic sequence, and I've done 31 questions in it. And if you watch that video, it is definitely going to change the way you think about arithmetic sequences. And it is not only going to help you in class 10th, it is also going to help you in the future classes, which is 11th, 12th, and even your graduation. So do not forget to go down into the description box below, watch that video, take that course, and it's a 90 minutes course, so it will take you some time, and you are going to understand all that in such a simple manner that you are really going to change the way you think about arithmetic sequences. Okay, so let's come to the question number 5. Okay, so question number 5 says that the ninth term of a sequence is -32, and the sum of the 11th and the 13th terms is 94, and we have to find the common difference of the sequence. So let's start again by writing down what is given to us. So we have been given that T9, which can also be written as A plus 8D. So A plus 8D is equal to negative 32, and the sum of the 11th and 13th terms. So let me write the 11th term. T11 is going to be A plus 10D, and the 13th term is going to be A plus 12D. Now the sum of these two terms is negative 94, so I can write that A plus 10D plus A plus 12D is equal to negative 94. Simplifying this, we can write it as 2A plus 22D is equal to negative 94. We can factorize out the 2 now, so it will be 2 outside the brackets, and inside the brackets we'll be left with A plus 11D is equal to negative 94. Dividing both sides of the equation by 2, we get A plus 11D is equal to negative 47. We can rewrite this A plus 11D as A plus 8D plus 3D is equal to negative 47. A plus 8D already from equation number 1 we know is negative 32. So negative 32 plus 3D should give us negative 47. Taking negative 32 to the other side, we get 3D is equal to negative 47 plus 32, which means that 3D will be equal to negative 15. And since 3D is equal to negative 15, we can say that D is equal to negative 15 divided by 3, which is equal to negative 5. So we had to find the common difference. So therefore the common difference of this arithmetic progression is negative 5. Now once we have learnt about the nth term of a sequence, the next step is to find out the sum of an arithmetic sequence, which is also called an arithmetic series. And I've done a video also on that. And if you want to watch that video, you can just click on this link here, which will take you to the sum of an arithmetic sequence. You can also click on my picture here so that you get subscribed to the channel, because I keep doing a lot of this stuff on this channel, and you must watch this video as YouTube recommends it a lot for you guys. And as far as the nth term of an arithmetic sequence is concerned, I think you've nailed it.